Hey there, science fans! Let's travel back in time, about 4.6 billion years ago. Can you imagine a time before our blue planet even had an atmosphere? It's true. Back then, Earth was a hot, molten ball of rock. There was no air to breathe, only a thin veil of hydrogen and helium surrounding the planet. These gases were remnants from the solar system's formation, but they didn't last long. Earth's gravity couldn't hold on to these light gases, and they eventually drifted off into space. Now you might be wondering, how did we go from no atmosphere to the one we have today? Well, get ready for some serious Earth science. The answer lies deep within our planet, with volcanoes. As the Earth started to cool down, volcanoes erupted, spewing out gases from the planet's interior. These volcanic gases formed the foundation of our early atmosphere. It was a steamy mix of carbon dioxide, water vapor, nitrogen and other gases. This early atmosphere was nothing like the air we breathe today. It was hot, thick and toxic. But as you'll see, it played a crucial role in shaping the Earth we know and love. Volcanoes played a pivotal role in shaping Earth's early atmosphere. Imagine fiery mountains spewing out massive amounts of gases into the sky. Carbon dioxide, the most abundant gas released by these eruptions, began to accumulate in the atmosphere. This increase in atmospheric carbon dioxide had a significant impact on Earth's climate. Carbon dioxide is a greenhouse gas, which means it traps heat from the sun. As carbon dioxide levels rose, the planet began to warm, creating a greenhouse effect. This warming was essential for the development of life as we know it. Without it, Earth would have remained a frozen wasteland, but volcanic activity wasn't the only factor at play. As Earth continued to cool, water vapor in the atmosphere condensed, forming vast oceans. These oceans absorbed some of the carbon dioxide from the atmosphere, dissolving it in their depths. This process helped to regulate Earth's temperature, preventing it from becoming too extreme for life to evolve. The emergence of life had a profound impact on Earth's atmosphere. Around 3.5 billion years ago, tiny organisms called cyanobacteria, also known as blue-green algae, appeared in the oceans. These microscopic pioneers possessed a remarkable ability. They could perform photosynthesis. Photosynthesis is the process by which plants and some bacteria use sunlight, water, and carbon dioxide to create their own food. The byproduct of this process is oxygen. As these early organisms thrived and multiplied, they released vast amounts of oxygen into the atmosphere. This marked a turning point in Earth's history. Over millions of years, oxygen levels in the atmosphere gradually increased. This had a dramatic effect on the planet. First, it led to the formation of the ozone layer, a protective shield in the stratosphere that absorbs harmful ultraviolet radiation from the sun. This made it possible for life to move out of the oceans and onto land. Second, the increase in oxygen paved the way for the evolution of more complex life forms, including animals, which rely on oxygen for respiration. Fast forward billions of years, and we arrive at the present day. The atmosphere we breathe today is a far cry from the toxic haze that shrouded early Earth. It is a delicate balance of gases, essential for life as we know it. So let's take a deep breath and explore the composition of our modern atmosphere. The most abundant gas in our atmosphere is nitrogen, making up roughly 78%. Nitrogen is essential for plant growth and is a key component of DNA, the building blocks of life. Next up is oxygen, comprising about 21% of the atmosphere. As we've learned, oxygen is crucial for respiration, the process by which we convert food into energy. While nitrogen and oxygen make up the bulk of the atmosphere, trace amounts of other gases play vital roles. Argon, a noble gas, constitutes about 0.93% of the atmosphere. Carbon dioxide, despite its small concentration, about 0.04%, is a potent greenhouse gas, trapping heat and influencing Earth's climate. Other trace gases include neon, helium, methane, krypton, and hydrogen. Section 5. Trapping the sun's warmth, the greenhouse effect. Now let's delve into the fascinating world of greenhouse gases and the greenhouse effect. Picture the Earth as a giant greenhouse bathed in sunlight. Some of this sunlight is reflected back into space, while some is absorbed by the Earth's surface, warming it up. As the Earth's surface warms, it emits infrared radiation, or heat. This is where greenhouse gases come into play. These gases, including carbon dioxide, methane, water vapor, and nitrous oxide, act like a blanket, trapping some of the outgoing infrared radiation and preventing it from escaping into space. This trapped heat warms the Earth's surface and the lower atmosphere, making our planet habitable. The greenhouse effect is a natural process that is essential for life. Without it, Earth's average temperature would be a frigid -18 degrees Celsius, 0 degrees Fahrenheit, too cold to support most forms of life. However, human activities are increasing the concentration of greenhouse gases in the atmosphere, leading to an enhanced greenhouse effect and contributing to climate change. Section 6. Our impact, human activities and climate change. Since the Industrial Revolution, human activities have been releasing increasing amounts of greenhouse gases into the atmosphere, primarily through the burning of fossil fuels like coal, oil, and natural gas. These fossil fuels power our cars, factories, and homes, but they also release carbon dioxide, the most significant contributor to human-caused climate change. Deforestation is another major contributor to the increase in atmospheric carbon dioxide. Trees act as carbon sinks, absorbing carbon dioxide from the atmosphere during photosynthesis. When forests are cleared or burned, this stored carbon is released back into the atmosphere, exacerbating the greenhouse effect. Other human activities, such as agriculture and industrial processes, release methane and nitrous oxide, potent greenhouse gases with even greater heat-trapping abilities than carbon dioxide. These gases, though present in smaller quantities than carbon dioxide, contribute significantly to global warming. Section 7. The evidence is clear. Climate change is real. The evidence for climate change is overwhelming and comes from multiple lines of scientific inquiry. Global average temperatures have been steadily rising, with the past few decades being the warmest in instrumental record, which dates back to the late 19th century. This warming trend is undeniable and is primarily driven by human activities. One of the most visible impacts of climate change is the melting of glaciers and ice sheets around the world. The polar ice caps are shrinking, and glaciers in mountainous regions are retreating at alarming rates. This melting ice contributes to rising sea levels, threatening coastal communities and ecosystems. Changes in precipitation patterns are another consequence of climate change. Some regions are experiencing more frequent and intense droughts, while others are facing more extreme rainfall events and flooding. These shifts in precipitation patterns can have devastating impacts on agriculture, water resources, and human settlements. Section 8. A toxic cocktail: atmospheric pollutants. In addition to greenhouse gases, human activities release a cocktail of harmful pollutants into the atmosphere. These pollutants not only impact human health, but also contribute to environmental problems like acid rain and smog. Let's take a closer look at some of the major culprits. Sulfur dioxide, released primarily from burning fossil fuels and industrial processes, is a major contributor to acid rain. When sulfur dioxide reacts with water and oxygen in the atmosphere, it forms sulfuric acid, which falls to the ground as acid rain. Acid rain can damage forests, acidify lakes and streams, and corrode buildings and infrastructure. Nitrogen oxides, also released from burning fossil fuels, contribute to smog, a hazy air pollution that can irritate the lungs and worsen respiratory problems. Ground-level ozone, a major component of smog, is formed when nitrogen oxides react with volatile organic compounds in the presence of sunlight. Particulate matter, tiny particles of dust, soot, and other pollutants, poses serious health risks. These particles can penetrate deep into the lungs, contributing to respiratory and cardiovascular problems. Section 9. Reducing our footprint, a path to a healthier planet. The challenges posed by climate change and air pollution may seem daunting, but there is hope. By reducing our carbon footprint and transitioning to cleaner sources of energy, we can mitigate the impacts of climate change and create a healthier planet for ourselves and future generations. One of the most impactful ways to reduce our carbon footprint is to transition to renewable energy sources like solar, wind, hydro, and geothermal power. These clean energy sources generate electricity without emitting greenhouse gases, making them a crucial part of a sustainable energy future. Energy efficiency is another key strategy for reducing greenhouse gas emissions. By using energy more efficiently in our homes, businesses and transportation systems, we can reduce our reliance on fossil fuels and lower our carbon footprint. Simple actions like switching to energy-efficient appliances, using public transportation and insulating our homes can make a significant difference. Section 10. Wrapping it up. We've journeyed through billions of years from Earth's fiery beginnings to the challenges we face today. Remember, understanding the chemistry of our atmosphere is crucial to appreciating the delicate balance that makes life on Earth possible. We've learned how volcanic activity and the emergence of life transformed our atmosphere, paving the way for the world we know today. Human activities, particularly the burning of fossil fuels, have led to an increase in greenhouse gases, contributing to climate change. The evidence is clear: rising global temperatures, melting glaciers, and changes in precipitation patterns are all consequences of our actions, but there's hope. By embracing renewable energy, improving energy efficiency, and making conscious choices to reduce our carbon footprint, we can create a healthier, more sustainable future for generations to come. So let's use our knowledge of science to make a difference and protect the only planet we call home. Stay curious and keep exploring the wonders of our amazing planet.